So I was just reminded to start recording, and I will make a quick run through of, we looked at yesterday's homework and classwork, and we were working with rational functions where the polynomial in the numerator and denominator had the same degree. And in this situation, when we did division, we found that this rational function, whose graph will have a horizontal asymptote of 0, is moved up 3 units. So what causes from the equation this moving up of 3 units to have a horizontal asymptote of 3? If the degrees match of the numerator and denominator, you should see that, let me erase this circle. If these degrees are the same, then the only thing I'm getting out of my quotient is a constant. And that constant causes a graph to horizontally move up or down when I add it to the graph of a function that I'm already familiar with. It's important to think about why this is true. If you have a polynomial of less degree in the numerator, then when x gets to being 100, 1,000, 1 billion, the denominator is so much bigger that this is heading to 0. And the same happens on the negative end of the x values, negative 100, negative 1,000, negative 1 billion. So that horizontal asymptote that was 0 is moved up to 3. And what I'm trying to do is help you see a pattern in how to determine horizontal asymptotes without going through an entire division process, because that's tiring. So if the numerator and denominator have equal degrees, then you do have a horizontal asymptote. You have a non-zero horizontal asymptote. Yes. Oh, I messed up, it seems, in uploading, which, yep, you're right. I gave you 2 answers. Okay, that happens sometimes. So, actually, oh, wait. If you go to print next week, let me show you. I have not under a category a print for next week. I have classwork 5.8 on there, the blank one. So if you need to print it out, go on there to print out the blank copy. And I'll fix that after class, but right now I need to keep going and make sure that I get through this lesson. So what we're looking at is if the numerator and denominator have equal degrees, then that rational function has a non-zero horizontal asymptote. And if you want to find the horizontal asymptote, the fastest way to do it, instead of going through a division process, is to look at the ratio of the 2 leading coefficients of the numerator and the denominator. this can be a little bit cumbersome to write. What? Oh, I'm recording. It's recording. I see. I moved the stuff that was in the way to my other screen that said it was recording. The horizontal asymptote is a ratio of the leading coefficients of the numerator polynomial and the denominator polynomial. I'm going to move down to letter C. If the degree in the numerator is less than the degree in the denominator, we already learned that that gives you a horizontal asymptote of 0. Now, you've only seen one graph, at least that I've given you, where the degree in the numerator was greater than the degree in the denominator. And I'm going to go find that. It was either from 5.2 or 5.3, and I don't remember off the top of my head. 5.3. Or maybe it was 5.4. Or maybe it was 5.3 because I'm not looking at the classwork. There we go. Ha! Do you remember this one? I had you graph this, and it apparently frightened some of you. You were like, that's horrible. This is an example of the numerator polynomial is greater than the denominator polynomial. I want to point out to you that when you do division, you get a quotient. And one thing that's very interesting, and I showed you with this graph, is if you graph this quotient with the rational function, do you remember seeing that the actual graph looked a lot like this graph on the ends? Not in the middle so much, where they were very different near this place where it had the vertical asymptote. But otherwise, it pretty much followed it very nicely in the end. Do you remember that? Whatever the quotient is, that is telling you the end behavior if you are to do the division. When I have a polynomial over a polynomial where the degree of the numerator is less than the degree of the denominator, I can't do division. There is no quotient. The horizontal asymptote is also 0. When I do division, when the degree of the numerator and denominator are the same, I end up only being able to go through division, one process of division. I get just a constant out of the quotient, and I have a horizontal asymptote that is that number exactly. But if I do division with, now I can't find it again. There we go. If I do division when the numerator that is being divided is a larger degree than the denominator, I will get a polynomial that is more than just a constant. And it'll actually follow that polynomial in the end. But I'm not going to make you go that far. I want you to be aware of it so that you can nicely just know that in the case where the numerator is greater than the denominator in degree, you don't have a horizontal asymptote. And at this level in math, that's all you need to be aware of, is just that you don't have a horizontal asymptote. What? So that part, what? So the parabola you graphed, yes, it actually is. And I'm getting a little bit ahead of myself on the math end. You guys do not have to be aware yet that there are asymptotes beyond lines. But it's actually pretty cool that there are. Asymptotes are just basically showing you places where the graph is trying to become that function, but just not able to do it. Something's holding it back. And for rational functions, the thing that's holding it back is the remainder. Having a remainder causes this to not be just the line y equals 3, but it will follow it in the end. Yeah. Yes. And that's what's really, really cool. It's fascinating to look at these and to look at what you can get out of these. So just be aware that anytime you're able to do the long division, the quotient is basically an asymptotic graph. That is, if you have a remainder. If you don't have a remainder, then that quotient is your graph. But if you remember back in 5.3, right before I had you graph this one, we did division. We got no remainder out of it. And we ended up just graphing the quotient, but we had to put a hole in the graph where it was causing a divided by 0, because anything that makes that denominator 0 on the get-go is out of the domain, no matter how much it'll simplify itself away. So this is really, really, we're coming to a bit of a conclusion of how far I'm going to take you with graphing in this particular classwork. The next classwork, I'm going to talk to you about certain categories called even and odd that we throw functions in. But this is it for what you are expected to know about graphing in this class. So these 3 things, and now I've got some examples for you. Right now, I'm leaving off y-intercept. On the test, I will ask you to find y-intercepts. But the most important things that are going to tell you the most about the graph are the 3 things that I'm asking you right here. X-intercepts, vertical asymptotes, and now you can find the horizontal asymptote. I am not asking you to graph these, although you can go to a graphing calculator or go on Desmos and graph them and see for yourself what they look like. So let's do these problems together. Number 1. Let's start with our new thing. Our new thing is horizontal asymptote. For number 1, is the degree of the numerator the same as the degree of the denominator? And then you guys said yes. Yeah, the numerator polynomial is degree 2. The denominator polynomial is also degree 2. And I just highlighted what tells us that it's degree 2. That means that it has a non-zero horizontal asymptote. And do you think you know what the answer is? I made this one something that I would never ask you to graph. What do you think is the horizontal asymptote of this one that I would never ask you to graph? Yes. It's not something you necessarily want to do by hand. You'd rather let some kind of computer do the graph for you when you're dealing with a fractional number for horizontal asymptote. But what I want to make sure is that you understand how to determine horizontal asymptote. So it is the ratio of the leading coefficients, the numerator's leading coefficient over the denominator's leading coefficient. Now, in previous homeworks and classworks, we have found x-intercepts and vertical asymptotes. X-intercepts are what make the numerator equal to 0. So I want you to factor the numerator and solve for what makes it equal to 0. Do you see that that numerator is a difference of squares? You got it. It's a difference of squares, so that means it's a conjugate pair when it factors. I'm going to start on the right end because 4 looks much friendlier. The square root of 4 is 2. Ba-doop, ba-doop. 9x squared, if you take the square root of that entire thing, you get 3x. So based on that factoring and solving for each factor equal to 0, the x-intercepts are, and I'm looking for someone to tell me what the x-intercepts are. And are all of you seeing this? Are all of you looking at it and seeing I'm solving 3x plus 2 equal to 0? So I subtract 2, I divide by 3, and that's giving me negative 2/3. The other one will give me a positive 2/3. I want to make sure all of you are seeing this. Again, this is a function I would not ask you to graph because the numbers are not what we would want. Okay, vertical asymptotes are the numbers that make the denominator equal to 0. So let's factor that denominator. And if you want, I can take you through the factoring process. Would you like that? Who will get something out of it if I go through the factoring process? I want to make sure that I'm not just doing this for my own enjoyment. Or do you know what the factoring is and you're ready to put it down? Tell me what you're ready for. I'm looking in chat. Okay. You don't speak for everyone, though. I've got to say that. Okay. All right. No one said that they were having trouble. So know that this is your time to speak up if you need more. When I factor, I get 2x plus 5 and x minus 2. Very good. So the vertical asymptotes are the x values that make each factor equal to 0. So what are those numbers? Negative 5 halves and positive 2. And I really wish I could just like walk around the classroom and see where you guys are at and if you have stuff on your paper. And this is very, very challenging for me to know if I should just keep going when I've got just a handful of people responding. But you will be quizzed and tested, so never be afraid to ask questions. Know that if you have a question, you are absolutely never the only one with that question. And it helps me to get a feel for where people are at. All right. So, number 2, let's start with horizontal asymptote. What is the degree of the numerator polynomial? And let me hear some answers from more people. What is the degree of the numerator polynomial? Okay, I know everyone wants to go on vacation right now, but I'm seeing like few webcams. Okay. Wanted to make sure I'm not just sitting here with 5 people because I know. How does the bottom not have a larger degree? Right. For number 2, the denominator polynomial is degree 2, while the numerator is degree 3. That means no horizontal asymptote. And if you did division on those 2 polynomials, the quotient that you get out of it would actually be a line, and it would create a slant asymptote. At least that's what they call it. So there is no horizontal asymptote. All you need to say is none or something that means that. Then x-intercepts. What makes the numerator 0? Yeah, so Jason, for this problem number 2, when you divide your degree 3 by your degree 2, let me just point this out on the side. When you start the division, this has to kick off with an x so that it multiplies to x squared to give you the x cubed. You're going to end up with a linear quotient. So you're going to end up with a line that is an asymptote. So it follows it. Off the top of my head, I don't know if it follows it one way or another, but it either follows it maybe like this. Sometimes they go like this. There are a variety of ways that they follow that, but it's really cool. Once you understand that that quotient literally gives you the end behavior, and it's an asymptote if you have a remainder, it's really interesting. You start seeing what you can do with these. Okay, so x-intercept. Yep, you can. You can get any degree polynomial as an asymptote. You just have to have that numerator polynomial much higher degree. Okay, does anyone see the x-intercept? In other words, what makes the numerator equal to 0? And other people see that too, right? Okay. And now just vertical asymptote. So factor that denominator. Two numbers that multiply to make negative 28 and add to make positive 3. And then and that will equal 0. Then when x is what numbers? And basically opposite sign. So I've got vertical asymptotes, 2 of them. So I didn't even account for the fact that this had 2 vertical asymptotes. And how about I show you what the graph looks like? Because otherwise this is terribly boring without the graphs. So I'm going to grab a Desmos and type this in real quick, and then I'll show you. if real quick is how I type. Okay, the denominator is x squared plus 3x minus 28. Okay. Did I type that correctly? Okay, something is wrong here. I'm trying to figure out what I typed wrong, and I'm having a problem, so I'm going to have to... Now I'm starting to waste time, which I did not want to do. Just give me a second. It's not typing where I'm asking it to type. So, how about you tell me what your plans are for your day off? Oh, I see. I wasn't looking out far enough. That's why I was confused. Haha. Okay. I had to zoom out of the graph. Are you ready? I'm going to move you guys back over here so I can see you. Oh, goody. Probably going to fix the roof tiles. Trim some ivy. Fun. What am I planning on doing? Hopefully not spending too much time grading the tests I gave today. But, you know, I will at least have a break from this ongoing push. Oh, that's good. Poison ivy, not fun. So if you zoom out on this graph, you can see that it has those two vertical asymptotes that we talked about. And you can see what I mean by a slant asymptote. The more I zoom out, the more you can see it. It looks like the line that is its quotient when you're looking really far away. Okay, let's keep going and get this done. Now let's go faster. Number 3, what is your horizontal asymptote? Anyone who hasn't been answering want to take a throw at this one? The degree of my denominator is 2. The degree of my numerator is 1. What is the horizontal asymptote? Thank you. Thank you so much. Yes, you got it. The x-intercept is what makes the numerator equal to 0. And what makes the numerator 0? What makes the numerator equal to 0? I'm pulling teeth here. Everyone sees it's -1, right? You just don't feel like reaching over to type the number. Vertical asymptotes factor the denominator. Right. If the degrees don't match, then you either have a horizontal asymptote of 0 or you don't have one. It just depends on whether you have the larger degree polynomial in the bottom or the top. When the bottom has the larger degree polynomial, then when x gets super big, you flatline to 0. But if you have a larger degree on the numerator, then when you head to infinity, it's growing up or down. And then the vertical asymptotes are what make the denominator 0, which is +4 and +2 in this case. And if you would like, I can real quick show you the graph. So I've got x plus 1, if I can find my Desmos. X plus 1, and just give me a second. It was x plus 1, and then minus 6x plus 8. X plus 1 minus 6x plus 8. And I am extremely zoomed in, so I'm going to push the house for home menu. You can see the two vertical asymptotes. You can see that the graph crosses the x-axis at -1, but very important, it's crossing the x-axis over here at -1, but it has to come back up to the horizontal asymptote. We can't see that very well. I have to zoom in a lot for you to see that the graph actually goes through that x-intercept of -1, and then it heads down a little bit, but it's got to head back up. I don't know. It has to head back up because it is being forced to asymptote to y equals 0. All right, let's take a look at the next problem. What is the horizontal asymptote on this one? If I can see a bunch of answers in chat, then I know that people are still with me here. Good. You got it. Or wait, hold on. Sorry. The degree of the numerator and the degree of the denominator, are they the same? There you go. You got it. So that means it's the leading coefficients. Since I don't see any, that means 1 over 1. I have a horizontal asymptote of y equals 1. My x-intercepts are found by factoring the numerator and setting it equal to 0. And that's going to be 6 times 4. Yep, you got it. So -6, -4. And my vertical asymptotes are what two numbers? You guys can look at that and instantly tell me, I think. X squared minus 25, you got it, 5 and -5. So let's take a quick look at what this graph looks like. I'm going to grab Desmos. I'm going to be able to type faster if I look here and type it there. So I've got x squared plus 10x plus 24, and then x squared minus 25. Okay, I've got it all typed in. Here it comes. How cool is that? That is really quite an interesting graph. It has the vertical asymptotes of 5 and -5 as we expected. It has the, I've got to go back and see what it was. It has two x-intercepts, -6 and -4. And you can see those right there. It has a horizontal asymptote of 1, but with this one, you're going to see it better if we go out a bit. And then if you go out far enough, you can see that this is heading to 1. And the other side is as well. When asymptotes are present, sometimes the graph just makes a beeline right to them, like instantly. Other times, you've got to be patient. And they eventually look like they're heading toward what is said to be heading toward. So a lot of fun graphs we can get when we are looking at rational functions. Okay, so you will have homework problems where you are just not worrying about the graph itself, but finding these items. Now, you're at the point where you can graph more. We have graphed problems like the 3 that I have ready for us to graph. You have done this before. As I'm looking at the time, I probably need to go faster than I want to go because I can't see your reactions very well. Take a good look at number 5. What makes the numerator equal to 0? Your answer is nothing. Nothing makes 5 equal to 0. The vertical asymptotes are the x values that make the denominator equal to 0. So if I factor, I get 5 and -2 for my vertical asymptotes. For horizontal asymptote, I look at the degrees. What do you know to be the horizontal asymptote? 0. You got it. Because the numerator is less degree than the denominator. So from here, these 3 things you really need to find before you start graphing. Then it's just a matter of how quickly you see things and how particular you want to be also. So I'm drawing the asymptotes. I can quickly find where this graph is if I do a number line. So if I do a number line and I'm saying like the f of x values are undefined, you get vertical asymptotes at -2 and at 5. It is never equal to 0. These are the only x values where I can change my sign. Have you noticed that most of the time you go back and forth between positive and negative? As long as you have an odd exponent, those exponents are 1s, although it looks like it's 0 because of the way I did that, but I wanted to just highlight. As long as you have just linear factors that are just that don't have a multiplicity going on to them, you will get a sign change every time one of those linear factors is equal to 0. So you can test numbers like I've said before. I can plug in a 6. If I plug in a 6, my numerator is positive no matter what. Denominator, all positives. If I plug in 0, I have a positive numerator. The factor x minus 5 is now a negative number. The other one is still positive. Then when I cross over here to, like, say, -3, this factor changes from a positive to a negative. Why can't I? And x minus 5 is still negative, and I get positive. So I have 3 sections. I am above the x-axis in the left section. In the middle section, I'm only underneath the x-axis. And then on the right, I'm above it. Now, I can plot more points to gain more accuracy. I didn't ask you to specify the y-intercept. You could have found it. If I plug 0 into the x's, I am going to get -1/2, -5/10. So that tells me I get way up there. But know that on the test, I will be clear about what you have to draw accurately. And if you want to draw more accurately than what I ask, just don't spend so much time on it that you can't leave ever. because you can always get more accurate. I'm only asking you to get to a certain level of accuracy, and this is good enough. So the plus means the line is above the x-axis. Yes. Because what I'm doing is I'm finding out if the function is giving me an answer that is positive or negative. And that gives me whether the y value is positive above the x-axis or negative below the x-axis. I want you to know something about this next one. Do you remember when we did the parent graph 1 over x? And do you remember that the next day we did division on problems that looked like this? You now can do these faster than when we did them in section 5.3. Let me show you back to 5.3. Or maybe it was, 5.3. For these first two classwork problems, we did long division, and then we took our parent graph and stretched and moved it. But now that you have more tools, I want you to be able to look at this and go, hey, that has a horizontal asymptote of 3, a vertical asymptote of 1. And then from there, you just have a little bit farther to go. And there's something that's very special about this type of rational function. And by this type, I mean the numerator and the denominator are degree 1 or less. Do you see that this one has a horizontal asymptote of 4? And as you look back on this division, it makes more sense now than it did back then. So anytime you have, when you don't have an x squared involved anywhere or a higher exponent, you will have somebody who is a child of this parent graph 1 over x. And what that tells you is a whole bunch of information. A 1 over x graph will keep a symmetry like this one. You can see is symmetric where it's in quadrants 1 and 3. If I multiply that by a negative 1, then my graph will change to being in quadrants 2 and 4. And you are guaranteed that if you have just a at most degree 1 on top and you have a degree 1 on the bottom, you will get somebody who is a child of this parent. And that means you have one vertical asymptote, one horizontal asymptote, and the graph exists in a pair of opposite corners every single time. And once you realize that, it can save you a lot of time with these. So with pulling together all the information we have, horizontal asymptote, do you see that that's going to be negative 2 for number 6? X-intercept makes the numerator 0. That's going to be 3. And the vertical asymptote is what makes the denominator 0, and that's going to be negative 1. Now, if you want to, you can find additional things that I didn't ask for to help you graph. Y-intercept can be very valuable. Mostly it's just an easy to find point. If I plug 0 into my x's, I'm going to get 6. The y-intercepts, again, they're nice because they're easy to find points. They're also important in word problems because they they represent the initial quantity that you have. So I'm just about out of time, but I'm plotting my X and Y intercepts. I'm drawing my vertical asymptote, -1, my horizontal asymptote of -2. And I have enough information to know that the graph exists here and it must exist in the other corner if it is coming from the parent graph. I've got the answers to the classwork. Oh, okay. I do not have those graphs. I will have to repost this. But for the third problem, I talk through a lot here. I want you to read over it or try to understand it. I'll talk about it more on Thursday. And I have a summary here of what I expect you to be able to know how to graph. I need to get your quiz going, so I'm going to have to stop here